Hello student, welcome to chemistry class with Emerald, and in this class today we are going to be looking at mole ratio and stoichiometry of reactions. This video is brought to you by Gothard Virtual Learning. What is mole ratio? What is stoichiometry? Stoichiometry is the quantitative relationship between the amounts of reactant used and the amounts of product formed. In a typical chemical reaction, you have the reactants and the product. For instance, A plus B giving C plus D. So to measure the relationship, quantitative relationship between the reactant and the product, that term is called stoichiometry. It is usually based on the law of conservation of mass, which states that matter is neither created nor destroyed in a chemical reaction. Matter can only change from one form to another, or no mass is lost in a chemical reaction. It also means that the mass of the reactant must be equal to the mass of the product in a typical chemical reaction. Now, in a stoichiometry equation or in a chemical reaction generally, we usually balance our equations. Note that the coefficient of reactants and products, they can represent the number of atoms as well as the number of moles that are reacted. The coefficients of a particular reaction, for instance, when you have ammonia reacting with nitrogen reacting with hydrogen to form ammonia, then you have N2 plus 3H2 to give 2NH3. In that case, each of those coefficients represent the amount or the number of atoms and the number of moles that are present in that reaction. Most do not directly tell us the mass of the reactant. However, we can convert moles to gram. We can also convert gram to moles, vice versa. Now, what is mole ratio? Mole ratio are used to compare the amount of reactants and products in a balanced chemical reaction equation. They are used to compare the amount of reactants and products in a balanced chemical reaction equation. The coefficient represent the number of moles, and then of course mole ratios are usually conversion factors in stoichiometry problems. Mole ratios are conversion factors in stoichiometry problems. Take for instance where you have magnesium being burnt in air to give magnesium oxide. The ratio of magnesium here to oxygen, the moles of oxygen molecules, the ratio is 2:1. That means the 2 mole of magnesium react with 1 mole of oxygen molecule to give 2 moles of magnesium oxide. Now, in mole ratio, you can use coefficient in a balanced chemical equation to write your mole ratio. You can use the coefficient in a balanced chemical equation to write your mole ratio. A mole ratio is a ratio between the number of moles of any two substances in a chemical equation. Like we have said before, another example is this: hydrogen peroxide decomposes to give oxygen and water. Here we know that 2 moles of hydrogen peroxide gave 1 mole of oxygen. So if you check very well, that is the coefficient, and that was what we are saying. The coefficient of hydrogen peroxide is 2. The coefficient of oxygen is 1. The coefficient of water is 2. So if you want to write about this equation, we can say 2 mole of hydrogen peroxide reacted with gave 1 mole of oxygen, or 1 mole of oxygen is equivalent to 2 mole of water in this equation. So the relationship that exists between them is that 2 moles of hydrogen peroxide produce 1 mole of oxygen and 2 moles of water. Or we can say the products of this reaction are oxygen and water in ratio 1 to 2. So these are how we can explain use coefficients to write the mole ratios. Now for mole ratios, like we have said, we can have stoichiometric conversions as far as mole ratio is concerned. So in this video, we are going to focus on mole to mole, how we can convert 1 mole to another mole, how we can convert mole to mass and mass to mass. However, note that we can also convert mass to volume, we can convert volume to volume, and even concentrations to volume. Those ones will be solved in the next video. So let's look at mole to mole conversion. In mole to mole conversion, when you want to determine the number of moles produced from a reaction, you must first begin with a balanced equation. So for every conversion we want to do, the first step to do is to balance your equation. In some instances, you might not even be given equation. You might be required to convert a chemical statement to a chemical equation. So you must be able to do this. But in most cases, you are given the equation, you must balance the equation. Now, after you have written your balanced equation, you need to identify the substances you know and the ones that you don't know. In a typical stoichiometric equation and stoichiometric questions or more questions like this, there is always the known and the unknown. It is the known that you are going to use to find the unknown. They might give you a clue and say 2 moles of this is used to produce oxygen. Then find the moles of oxygen. So you are going to be given the known so that you can use the known to produce the unknown. So the next step is, after you have identified the known and the unknown, is now to use mole ratio to determine the substance that you need to find. Now let's take a typical example. A vigorous reaction between potassium and water produces hydrogen gas and potassium hydroxide. Then let's say the question now continues and say, how many moles of hydrogen are produced if 0.04400 moles of potassium are used? Let's assume that's the question. Now the first thing to do is to write a balanced equation. Potassium solid is a metal reacting with water. It will produce potassium hydroxide and hydrogen. You write the equation, then you balance. So there is a balanced equation there. Now the next thing is to look at what is the known here. The known here is potassium. Potassium is, here. You are given 0.0400 moles of potassium and you are looking for the moles of hydrogen. The known is potassium, the unknown is the moles of hydrogen. Now you are now going to use mole ratio to find it. How do you use mole ratio? Then you say that since you are dealing with potassium and hydrogen, we can say that 2 moles of potassium from that equation now, 2 moles of potassium gave 2 moles of potassium when reacted with water gave 1 mole of hydrogen. So therefore 0.0400 moles will produce X mole of hydrogen. So we can use that one. So if you say 2 moles of potassium is equal to 1 mole of hydrogen, then 0.400 mole of potassium is equal to X mole of hydrogen. If you cross multiply, you are going to have 2x is equal to 0.0400. Then if you divide both sides by 2, your x will be 0.0200 moles of hydrogen. You can use that method. Secondly, you can also use it by saying that moles of known multiplied by mole ratio is equal to moles of unknown. That's another method to use. The moles of known multiplied by mole ratio is equal to moles of unknown. And the moles of known is 0.0400. The mole ratio here between hydrogen and potassium here is 1:2. 1:2 or 1/2. So 0.0400 times 1/2, then it will give us most of the unknown. So yeah, that's times 1/2 will give us 2 in 0.0400 will give you 0.0200 mole of hydrogen. So note that the mole ratio should be the moles of unknown over the known. Please take note. The formula you want to use is, if you are using this formula, your moles of unknown is equal to moles of known times mole ratio, and then your mole ratio should now be the moles of unknown over moles of known. Please take note, and that's why we use unknown, which is 1/2. Please take note of that. It's very important. Okay, now we can also have mole to mass conversions. For instance, you know the number of moles of a reactant or product, and you want to calculate the mass of another product or reactant. The way we have used mole ratio to find from mole to from known to unknown, that's what we are still going to use. The only difference is that here, once you have gotten the moles, we have to convert to mass by multiplying by molar mass. Remember that number of moles is equal to mass over molar mass. Then therefore, mass will now be equal to number of moles times molar mass. So whatever we get from the moles we've gotten, we can multiply by molar mass. So let's take an example. The question says, how many grams of glucose are produced when 24.0 mole of carbon dioxide react in excess water? There are two ways to do this. Let me explain. If you are to write the equation out, if you have written it very well, you are going to have 6 CO2 gas plus 6 H2O liquid will produce 6,6H12O6, which is glucose. That's the balanced equation. That means 6 moles of CO2 reacting with 6 moles of water will give 1 mole of glucose. Now, you have been given the actual mole of CO2, which is 24.0 mole. So you can now say that because the major reaction or the major relationship there is between CO2 and glucose, you can say stoichiometrically now 6 mole of CO2 produce 1 mole of glucose. Then 24 mole of CO2 will produce X mole of glucose. So 6 mole is equal to 1 mole, 24 mole is equal to X mole. If you cross multiply, you are going to have 6X to be equal to 24 times 1. Then X is equal to 24 over 6, and that is 4 mole of glucose. So 4 mole of glucose is the actual mole of glucose from this reaction. And if you are not going to do that one, you can say that 24 mole of CO2 multiplied by 1 mole of glucose over 6 mole of CO2. Don't forget, we are saying to get the unknown, go back to this reaction. Moles of known times mole ratio is equal to the moles of unknown. And that is what, again, we have done here. This is the moles of known times mole ratio. And the mole ratio is the mole of the unknown over the mole of known. That is 1/6. Your unknown is glucose. That's 1. The known is CO2 over 6. So in writing the mole ratio now, don't forget unknown over known. So that's why we have 1/6. The moles of known, 24 over mole ratio 1/6 will give you moles of the known. Now, after you have gotten the moles of the unknown, the next thing to find the mass is to multiply by molar mass. since we have gotten the mole now. So, and the molar mass of glucose is 180.18. So that's 4 multiplied by 180.18 will give us 721 gram of glucose. So therefore, 721 gram of glucose is produced from 24.0 moles of carbon dioxide. 721 grams of glucose is produced from 24.0 moles of carbon dioxide. Okay, again, you can also have mass to mass conversions. In mass to mass conversion, you are still going to use mole ratio and then mole over mass calculations to determine the masses. In mass to mass conversion, you are going to be given the mass of a particular substance, or you are going to have the mass of the known, and then you are going to look for the mass of the unknown. So the first thing again is you write your balanced equation. The mass, you convert the mass of the known to mole by dividing by molar mass. So after you have converted it to mole, you use mole ratio to determine the mole of the unknown. You use mole ratio to determine the mole of the unknown. Then when you have gotten the mole of the unknown, you now convert it back to mass by multiplying by molar mass. Now let's take an example to look at this. In the question here, the question says how many grams of NaOH are needed to completely react with 50.0 gram of H2SO4 to form Na2SO4 and H2O. Look at that equation. That's the step 1. Sodium hydroxide reacting with H2SO4 to produce sodium sulfate and water. Stoichiometrically now, in terms of the what's it called now, mole ratio, 2 moles of sodium hydroxide reacting with 1 mole of sulfuric acid to give 1 mole of sodium sulfate and 2 moles of water by interpretation. Now the mass of the known that you are given is the mass of sulfuric acid. The mass of sulfuric acid, and you are looking for the mass of sodium hydroxide. So the first thing is to convert the mass of this sulfuric acid to mole by dividing by molar mass. So the first thing is to find the mole of H2SO4, and you do that by dividing by the molar mass of H2SO4, which is 98.09. So if you divide 50 gram by 98.09, you are going to have 0.510 mole of H2SO4. 0.510 mole of H2SO4. That's step 2. Step 3 is by the time you have gotten the mole of H2SO4, which is the known, we now go ahead to use mole ratio to find the mole of the unknown. How do we find the mole of the unknown? Back to that formula. The mole of the unknown is the mole of the known times mole ratio. And then the mole ratio, don't forget, is the mole of the unknown over the mole of the known. So if you are looking for the actual mole of the known now is 0.510 times mole ratio, and the mole ratio is mole of the unknown, which is 2, over mole of the known, which is 1, and it will give you 1.02 mole of NaOH, which is the unknown. So we have looked into the mole of the unknown now, which is 1.02 mole. Now the last step is to now convert the mole of that unknown that we have gotten now back to mass by multiplying by molar mass. So we have to multiply by molar mass of NaOH, which is 40. So you are going to have 1.02 multiplied by 40, and that is 40.8 gram of NaOH. Therefore, 50 gram of H2SO4 reacts completely with 40.8 gram of NaOH. So that is where we are going to stop for this class. In the next video, we are going to look at the limiting yield and percentage yield, and the limiting reagent and percentage yield. But much more importantly now, we are going to look extensively at the mass to mass problem, the mass to volume problem, and the volume to volume problems. And now we can use mole ratio to solve them. And additionally, we are going to solve some wire questions. So in the next video, this is what we are going to do. Continue to learn chemistry, and see you in the next video.